question types. They are table analysis, two-part analysis, graphics interpretation, and multi-source reasoning. Out of these, the first two question types, that is table analysis and two-part analysis, come in two variants each, which means on IR we could be looking at 6 different question formats. In this video, we'll take a detailed look at each of these question types, and we'll also discuss the methods and techniques you can use to tackle them effectively. And at the end of the video, I'll also touch upon some IR scoring strategies. We are going to look at 4 question types within integrated reasoning. 2 of these question types have 2 variations that come within the question type. So the first of those 2 is table analysis, and there are 2 variants that we can get within table analysis. We'll look at one example from each of these 2. So this is the first question we are looking at. Now, one of the tools that you have to make use of to the fullest, and in fact, table analysis is mainly about using this tool effectively, which is the sort tool. So as you can see here, there is a drop down, and I can sort on whichever column I want as per the question. So you can take a look at this question. The objective of this question is to choose yes if this statement, so there are 3 statements that we are reading here. We have to choose yes if it can be shown to be true based on the information in the table, otherwise no. Which means what we are checking is that does the table lead us to this particular statement, yes or no. So this is in a way a possible conclusion which we are trying to defend with the help of the facts given in the table. So this is one of the question types where the options columns, as we are seeing here, will be yes or no. These 3 are the possible statements. This whole thing is one question on IR, which means these are 3 sub-questions belonging to the same question. And to get this particular question right, we will need to get all 3 sub-questions right. If one of them is wrong, it goes wrong. So these are the 3 statements. Now we will run through them one by one and check how to basically go about with it. As I said, mainly it will be using the sort tool in the right manner. So the very first statement that they're giving us here. Now, before that, let's just understand what the table is about. It's about Brazilian agricultural products in 2009. These are the products we are seeing here. These are the columns telling us what kind of information is given about those products. So for the first statement, it says no individual country produces more than 1/4 of the world's sugar. We want to mark a yes whether we can say such a thing from the table, or no if we cannot say such a thing from the table. So for that, the first thing we will do is scan the table for sugar. So here is where the data for sugar is. The percentage share for Brazil, this is data for Brazil, is 21%. The question is no country in the world. We have data only for Brazil, which is 21%. There can be another country at 22%, or there may not be another country at 22% or 25% or 30%. However, the second column gives us the rank of that country, which in this case is Brazil. And it shows us out here that the rank is 1 for this commodity sugar, which means at 21%, Brazil is the world's top producer of sugar. If this is known to us, the statement no country produces more than 1/4 of the world's sugar now definitely becomes true. So we have to click this radio button and mark a yes for the first one. Now we have to move to the second statement. The second statement says if Brazil produces less than 20% of the world's supply of any commodity in the table. So here we are talking of, again, produces, and we are talking of 20%. So we need to sort by production world share. Once we sort, it has sorted this in ascending order. We are dealing with less than 20%. So basically, this is where we will stop. All these values we are going to look at now. And what we have to check is that if Brazil share is less than 20, which it is for this, for this, for this, for this, and for this, these 5 commodities, it is not the world's top exporter. But for these 2 categories, it very much is the world's top exporter. So we can now conclude that this is a false statement. We cannot infer this based on the data. So we click this particular button out here. Now the third one says, of the commodities in the table for which Brazil ranks first in world exports. So for this particular question, we are discussing world export rank, which is given in this particular column. So the first thing to do is sort by world export rank. Once we have done this, we know that all these countries are ranked first in world exports. The statement says Brazil produces more than 20% of the world's supply. Now, if you compare the world's supply, here it does, here it does, here it does. But here it doesn't. All these will qualify. And for 2 out of 5, it does not. Hence, we cannot generalize and say that this is a true statement. So for this statement also, we have to mark it as false. Okay, so this is the way we'll go about. Table analysis is an extremely scoring question type in IR, and you have to try and get all correct out here. As we are seeing, we are not really doing any kind of number crunching. We are just sorting according to the need and then looking at the relevant rows or columns to answer questions. That's how it's going to be on all questions in this category. So as I said, this question type comes with 2 variants. We have just finished discussing the first variant. Now we will move on to the second variant. So take a look at this information. So just as we saw in the previous question, here again we have a table. Data is given, as we can see, percentage of population visiting selected cultural institutions single year. So for a particular year, for all these countries or regions, we are given the percentage of the countries or the region's population visiting the library, visiting the zoo or aquarium, and so on. But there's a very big difference which is now coming in out here in the question, which is that in the earlier question, we had a yes and no. In this question, it says would help explain and would not help explain, which is what we are seeing here. And the question you have to ask is this the same as yes and no? In other words, is it just that the wordings have changed, or are we supposed to do something different? Any thoughts you would like to share? Do you think would help explain and would not help explain would more or less boil down to yes and no only, or will it be something else? No. Enough of CR is there in on verbal and AWA. And CR can come in IR, but not for this question at least. Okay, so I'll tell you what exactly this means. Now, this is first of all not the same as yes and no. Would help explain. Let's read the wording carefully. For each of the following statements, select would help explain if it would. If it would means if this statement would. If true, if assumed to be true, means whatever is being told to us from year to year, let us assume it is true. And if true, will it help explain some of the information in the table? Which means if this is known to us as a fact, And that's where it differs completely from the previous question, where these statements were playing the role of a conclusion. So in the earlier question type, where we were concluding yes and no, the three options were playing the role of providing us with three possible conclusions, and we were verifying whether it follows or not, yes or no. On this question, on the other hand, the three statements are now playing a role of providing us information, facts. And if this fact is true, we are checking whether it explains some of the stuff that we are seeing in the table, which means in the table, let's take a look at any random data. We are looking at the fact that this 5% for Russia is the lowest for natural history. Okay. Now the question is that if this statement is true, does it explain why that data is like that, the way it is? How come Russia is right at the bottom of the list in terms of percentage? That's the call we are going to take. Okay. So we'll treat the statement as a true fact. And we have to ask that if this was told to us, will it clarify? In other words, when you look at the table, when you look at some data, you might have a question, how come the data looks like this? Does this fact clarify that for you? Does it explain? If so, we'll mark would help explain. If not, we'll mark would not help explain. Okay, so that is basically what we have to do on this question type. Now let's start with the first statement. So in the first statement, we are told the proportion of population of Brazil that lives in close proximity to at least one museum is larger than that of Russia. So on this question, we are comparing two regions, Brazil and Russia. Fortunately, they are already present at number 1 and number 2 in the table. So there's no need to do any kind of sorting. They're already adjacent to each other. We are being told that the proportion of population of Brazil that lives within close proximity to at least one museum is larger than that of Russia. Now, if we look at, this is about library. This will not matter here. This is about aquarium data. This statement is not telling us anything about aquariums. It's talking of only museums, which is given in columns 3 and 4. As we can see, for Brazil, it's 7%. For Russia, it is 5%. Russia is below Brazil in terms of percentage of its population visiting this museum. And we see the same thing happening for science technology. Brazil is at 4%, but Russia is only at 2%. So what we are seeing in the table is that a lower percentage of Russian population tends to go to these two museums versus Brazilian population. The question now we are trying to answer is that if this fact is known to us, does it throw light on what is going on out here? What do you think? Yes or no? Does it help explain what is going on out here in a way as a possible explanation, not the only explanation, but as a possible explanation, or does it not? What do you think? Yeah, so the answers are correct. It would help explain, because clearly if this is true, that more Brazilians, or a larger percentage at least, lives close by to a museum, it is quite likely that they tend to visit a museum more often, and therefore it's a logical explanation. So for this particular thing, we will mark would help explain. Job is not done. This question is not over. It's only one. There are 3 sub questions, and we have to get all 3 correct to get 1 question right out of 12 on IR. So 2 more statements to be looked at. Let's look at the second one now. It says, of the countries, unions in the table, Russia has the fewest natural history museums per capita. Now let's see, what do we know about Russia from the table? What we know already about Russia is that, and this is talking of natural history, which means we are only concerned with this particular column right now, not the others. In natural history, we also know and we can verify. In fact, it's quite obvious visually, but if you just want to verify it, we can always sort on natural history. And you find that Russia, in fact, is the lowest. So at 5%, the numbers for Russia are the lowest in terms of percentages. Only 5% of Russians visit a natural history. 7% of Brazilians go to this kind of a museum. For South Korea, it's 30% of South Korea's population visits a natural history museum, 27% US. How come it is so low in Russia is what we might be curious to know. Does this statement explain this to you? What do you think? Yes or no? Yeah, so the answers that we have got are correct. It would help explain, because when you say fewest per capita, it means per person they have the fewest museums. What it means is that for every 100 people, if in Russia it is say 3 museums, then in the US it could have been maybe 10 museums or so. And if that is the case, the chances that more people are likely to go as a percentage to a museum automatically improve. Okay, so if this statement is given to us, it does explain why the data for Russia is the way it is, why it is at the bottom of the list in terms of percentage of people visiting natural history museum. Because for every 100 Russians, there is only 1 museum or 2 museums, versus other countries there may be 7 museums, 12 museums, 15 museums to visit. So that is one of the factors that could influence how many people for every 100 go to such places. Now we come to the third statement. So it says that of the countries unions in the table, the 3 that spend the most money to promote their natural history museums are also those in which science is most highly valued. Now, if we have already sorted on natural history, so here we can already see that the 3 top countries in terms of, in fact, there's a tie here. So these are the top players in terms of percentage of their population visiting natural history. Here we are saying the 3 that spend the most money to promote. First of all, it is not necessary that for those countries that spend the most money, majority of people also visit. They might spend money, but they might be wasting their money also. So we have no automatic correlation between spending money to promote a museum and percentage of population actually visiting the museum. Secondly, even if for some reason you were to assume this to be true, that there has to be a correlation, when we check with science is most highly valued, which again we have to assume that therefore they visit the museum, which is fine. If it's valued, they're likely to visit a science museum. We don't see a correlation in terms of top data out here. We see countries such as this 19%, China much higher, but it's not in the top 3. So whichever way we look at it, it's very easy to conclude that this information is not throwing light on what we want to check in the table. So we will mark would not help explain. With this, we finish this question, and when you submit your answer, if all 3 that you are marking out here turn out to be right, it's counted as 1 correct answer. So you have to be careful, because 2 right, 1 wrong is meaningless. But as I said earlier, this is really the main challenge on this question type, and table analysis is one of the better questions to tackle in IR, and ideally you should try and get all your table questions right. Okay, so now we will move on to the second question type. So this question type is called two-part analysis. We can see the columns coming here, two parts. The answer will be in two parts. I'll either find that this and this is the correct combo, or this and this is the correct combo, or something of that sort. So I have to work out a correct combination out here. This question comes in two variants, and what we are seeing is the first of those. So out here, the kind of information we are looking at is non-mathematical. In fact, it is more logical. So this is one of the question types that you get in two part, which is where there is just logical information given and you have to solve. And the other, which we'll see after this, is where there is mathematical information given. So both things come on this question type. Let's start with this question. I'll give you some time to go through it, try and work it out on your own, and then we will discuss. So I've just marked out the key conditions out here. Total 5 writers on each day is one of the conditions. This is important. It doesn't say day 1 and day 2. It says one of the days, which means we don't know which of these conditions applies on which days. Okay, which means this condition can be for day 1, this can be for day 2, or vice versa. So on one of the days, we want majority to be writers whose language is not English, which means out of 5, if you want a majority, you can have max 2 English. That's one of the restrictions we have. On the other day, at least 4 women we want. So these are the two main conditions. Neither day, which means this applies to both, should have more than 2 from the same country. So this is an overlapping condition. And now already they are saying 4 out of 5 have been identified for day 1 and day 2. One more member has to be added. Now look at the question. They're asking us, select a writer who could be added to the schedule for either day. Which means suppose we check out, suppose we mark this guy as the answer for either day. Not guy, sorry, she's a lady. So you can send her here, you can send her here. Okay, that's what it means. And then select a writer who could be added to the schedule for neither day. Which means again, if we were to select her for neither day, she cannot go here also, she cannot go here also, because she violates both the conditions. So that is the combo we need to identify. The only way to proceed is by looking at each one of them and checking whether he or she fits on one of the 2 days or on both the days or none of the days. And that will tell us what to mark. So let's start with the first one. She's female. Now before that, we don't know which day which condition applies, but here we already have 2 males on day 2. If we already have 2 males on day 2, the min 4 women condition can never be met on day 2. So this therefore becomes the condition for day 1, and this becomes the condition for day 2. Okay, so that's how we can derive which check applies to what. Now she's female, which means she's eligible for day 1 because that criteria is not being violated. She's English, and on day 1 there is no English restriction, so even that criteria is not getting violated. And she's from the USA, so again the 2 country is not being violated on day 1, which means she can go on day 1. Can she go on day 2? If she comes on day 2, the condition is max 2 English. That gets violated because she is also English, and you already have 2 English. So there's no way we can put an English person on day 2, which means she can go on day 1, she cannot go on day 2. What we want to mark is either day, which means she can go on both the days effectively, or neither, which means she just can't go. But in her case, it is 1 each, so she will not qualify to be an answer. Next, we move on to this person, Longfellow. Longfellow is male. For day 1, we cannot have a male because we need at least 4 female members. So Longfellow cannot go on day 1. On day 2, if Longfellow enters, he's English, and we need max 2 English. We already have 2. So Longfellow cannot even go on day 2, which means we have identified the person who can go on neither of the 2 days, and that is Longfellow. So let's click the radio button for Longfellow for neither of the 2 days. This is where this person belongs. Now we check Murasaki. So she's female, means she's eligible for day 1. She's Japanese, so she's not violating the 2 country on day 1. Sorry, she's not violating, there's no language restriction in fact on day 1. She's from Japan, so she's not violating the 2 country rule for day 1. So she's eligible for day 1. Murasaki can go on day 1. What about day 2? On day 2, max 2 English, but she is Japanese. So she's not going to violate this rule. She's passing this check also. Max 2 from the same country. There is nobody from Japan, so she is in no way going to violate that requirement also, which means Murasaki is eligible for day 2 as well. And we have found the person who can go on either of the 2 days. So for this, again, we mark this radio button out here. And that's it. There's no need to check. If you know you have done your rough work right, there's no need to check. If you have time, you can verify the remaining. But this is the combo we were looking for, and this is how we have to deal with this question type. So this is one of the variants of 2-part analysis, wherein the data will be mostly logic driven, and you will have to do some such logical working to answer the question. Yeah, so the question is, how did we arrive at which condition applies to which of the 2 days? See, that one condition says that you need majority to be non-English, which means maximum 2 English, and the other says you need at least 4 women. Now this women requirement, which is there, at least 4 women, there is no way you can apply it to day 2 because you already have 2 male members. So no matter whom you take on day 2, there is no way you'll have 4 women, which means this condition doesn't apply to day 2. Therefore, it has to apply to day 1. And the other condition has to apply to day 2 by default. That is how we figured out what applies to which day. Okay, now we will look at the second type which comes in this, which is numeric data. Okay, same question structure. What has changed is the nature of the information. Earlier we had logic driven. Now you can very clearly see we are looking at numbers here, numbers here. We are looking at numbers in the options, rate of increase, jargon is coming in. All those things are happening here. So this is math driven. So I'll give you some time to go through it, try to solve it on your own, and then we'll discuss. So if you have started doing a lot of paperwork, you are doing the wrong things for this question. In the IR, you have an online calculator available. You can make use of it, but ideally you shouldn't use it. So this question is not about compounding or something. If you have mistaken it that way, you can get into a lot of calculations. Let's understand how to solve it. First, summarize the facts. So organization A starting at 1050. B starting at 1550. Both are going to increase annually, each at its own constant rate. Analysts project that if each of these maintains the constant annual rate of membership increase, 5 years from now, they will for the first time have the same number of members. So A is starting right now at 1050. B is starting at 1550. They'll keep on adding members year after year at a constant rate. And 5 years later, for the first time, they will converge. And in subsequent years, A will have more than B, which is obvious because A is obviously growing faster in order to catch up. And once they catch up, A will overtake also and move ahead. Now in the question they're asking us, identify a rate of increase in members per year. So this is an important thing to understand, and it's repeated here also for you. It's given here also for you. That when we say rate of increase, we are not talking of a percentage rate. This is not about compounding. Otherwise, even with a calci, it will take you some time. This is about actual membership increase, which means if I'm marking this 10 out here for A is adding plus 10 members every year, 10, 10, 10, 10, not 10% growth. Similarly for B. So we have to work out the rate of increase in members per year for A and the rate for B, that together are considered with the projection, and mark only one. So this is what we have to do, the correct combo. How much should A add and how much should B add, which as a combination will ensure that 5 years later they meet. How to go about with this? Multiple things you can think of. Trial and error is possible. You can explore the options, plug them in, check them out. All that is possible. You might get answers, but it will take longer. It's very easy, in fact, to tackle this question. The first thing we have to take note of is that the way things stand today, B has a lead of 500 over A. Okay, it's like a race. B is ahead in the race, A is lagging behind, and the lead that B has over A is of exactly 500. A's target is to catch up with B. When we say catch up with B, it means reduce this lead of 500 down to 0. They are together now, there is no gap. So right now there's a gap of 500. We have to bridge this gap and make it, narrow it down to 0. And for this, we have 5 years time. And clearly it's being done uniformly every year. Therefore, per year, the gap will have to narrow down by 100. And if A is able to narrow the lead by 100 over B in the first year, then another 100 in the second year, then another 100. In 5 years' time, A will successfully catch up with B. So this is really the solution to this question. And this is in fact true for all the questions, at least that I have seen of this question type, where it's not about number crunching and calculations. There is some connection between the two radio button columns. Okay, and you have to just identify that connection. This connection out here we are seeing, it's about a difference. In some other questions it's about a multiple also, or a ratio. So these are common connections that you might want to look for, and then once you see the correct combo, you will see, okay, if this goes this way, this goes this way, we are achieving what we want. So on this question, what we have concluded so far is that A has to cover up 100 over B every year. When we say A has to cover up 100 or gain 100 or narrow the lead by 100, whatever B is gaining, suppose B is adding 18 people, then to cover up by 100, A will have to add 118. If B is adding 94, A will have to add 194. Okay, so that's really what it means. Now we have to go to these columns and check which two buttons should I mark such that the gap is exactly 100. And secondly, who has to be higher? A has to be higher than B, because A has to be plus 100 of B. So we want a gap of 100. If you look at these numbers, if you say 10, suppose B is 10, then A should be 110. There's no such number. If B is 30, A can be 100. That's a good combo we already have here, which has to be the answer because there can't be two answers. And for the others, we don't have. So this is what we have found, that B will add 30. This is where it is. This is shifted down by 1. And A will add 130, the second last. When this happens, the gap is exactly 100, which means A has gained 100 over B. And that, and this way, in 5 years, A will gain 500 over B and bridge the gap down to 0. So this was the correct combo. There is no unique set of answers. There can be infinite answers for this question. But when they give you these options, they will only give you one pair which is possible out of the options. Okay, because Otherwise, there can be multiple answers. For example, if they are given you 110, then even 10, 110 is a possible combo for B and A. But they will only give you one valid combo out of the options, and that is what you had to pick up out here. So this was an example of two-part analysis, numeric type. Now let's move on to the next question type, the third question type, graphics interpretation. Graphics interpretation means some such graph will be given to you and two questions will be asked with drop downs. You have to answer both of them, and if both of them are answered correctly, you get the question right. So the first thing we normally want to do when we see a graph or a table is to read its title. So here you're talking of this Tyrannosaurus Rex, mass in kilograms by age, and that's again overlapping with the axis labels, which is another quick thing to check. So on the y-axis, it's the mass in kilograms. On the x-axis is the age of this Tyrannosaurus Rex in years. And this graph is connecting his weight to his age. Some more things given here in the narration, that these 3 points A, B, and C correspond to 12 years, 16 years, and 20 years. This is 12. In fact, you could have done that this way also by projecting it down, and that would have been 12. So they're already telling you that this is 12, this is 20, oh sorry, this is 16, this is 20. So these are the 3 dots. And we have been asked 2 questions based on this. Okay, so you can try to solve them on your own first. Do keep in mind, I've already shown you the drop down. So the options are giving us quite a broad range. Okay, so we don't need too much of accuracy out here unless it comes at the borderline, like close to 3000 or something, then you need to know which side of it. Otherwise, the options are giving us a broad range to choose from. You can even use your calculator right now, your mobile, because you'll be allowed to do so in the IR if at all you need to make any calculation. All right, let's discuss this. So for the first sub question, for values of age from 12 to 30, which means from point A right till the end, all these values, the average mass falls approximately between what, and as we saw in the drop downs, there's a broad range. Now, how do we go about with this? What we are looking at is this curved portion. Okay, we are looking at something like this. And in this region, we have to work out an average. This is 20. This is A, and this is B. Now, how do we go about with this? What we'll need to do here is split it up into 2 parts. It's almost like a line. From year to year is almost like a line. And then this part again is almost like a line. Okay, that's really the way we'll have to look at it. We don't need accuracy in any case. So from A to C is almost a straight line, as you can see. And the midpoint of a straight line, or rather the average of a straight line, will always be its midpoint, which overlaps with B. So one of the things that we know is that for this straight line, the average is equal to 3000, this value. And for this straight line, which is here, we can say it's approximately 5500. Okay, so this is what we know in terms of averages. The question is, can we simply add them up and divide by 2? We could have done that, which only if the weights were equal. Now here we are talking of 12 to 20, which means here we are talking of 9 years. And here we are talking of 21 to 30. So here we are talking of 10 years. The weights are almost equal. The ratio of weights is almost 1:1. Okay, 9:10. So for all practical purposes, we can very well assume that the weights are equal and hence take their simple average, which is 3000 plus 5.5, which is 8,500 divided by 2. That's roughly 4,200. So out of the options, it has only to be this particular option. Clearly the answer is higher than 4, because one of the things we also know that most of these numbers in fact are much above 5,500. So this value is higher. This 10 years has a higher weightage slightly than 9, so it's going to pull it closer to 5.5 slightly. The simple average is already 4,250. So we know without doubt that the range has to be higher than 4,000. So this is the answer to the first sub question. For the second one, they're asking us percent change in mass from 12 to 16. Now at 12, let's just put the values first. At 12, the mass is around 900. At 16, the mass is exactly 3000. They're asking us to calculate percent change. Now you can do it by subtracting and all multiple ways. You have access to a calculator. So the easiest thing to do on the calculator when you use the calci would be like 3000 divided by 900 you can do. I'll just tell you how much it works out to be. So this is giving me 3.33 on the calci, which is telling me that 3000 is 3.33 times 900, which is 333% of 900. Therefore, the increase is 233%, always 100% less. Okay, if a number is say 150% of another number, it means it's 50% higher. So, or you can do the conventional subtraction. If this confuses you, you can simply say 3000 minus 900, 2100 divided by 900 into 100, and that will give you exactly what we are writing here, 233%. So this value we have worked out. Okay, this value 233%. That they want us and say this is approximately, and look at the options here. The options are saying equal to 2 times, 3 times. What? The second half of it is the percent change in mass from 16 to 20. So 16 is again, 16 is 3000. We already know that. And 20 is becoming roughly 5200. So again on the calci you perform such a division and let us see how much we get. So that works out to 73% approximately. And now the question is that this value 233% change is how many times this percent change, and clearly we can see 7 3s are 21, so this is a multiple of 3. So that is what we had to mark for the second sub question, and when we submit, this is counted as one question in IR out of 12. Okay, so this question, yes, it did involve a little bit of calculation, but you have a calci in case you need to. Orally also, it wasn't very difficult to approximate. So if you just subtract these two numbers, it's 2100 divided by 900 is almost divided by 1000. So getting roughly 210% or so was as it is very easy, and the same thing you could have done for the second calculation, but it's okay, you have a calci, you can make use of it on such calculations if you need to. Okay, and now we have to take a look at the last question type in IR. which is called multi-source reasoning. Multi-source, they use this word because we are seeing three sources. Email 1 is one source, email 2 is another source, email 3 is yet another source. Out here it's only emails, therefore it's only text. On some other questions it could even be graphs or tables. You have to devote time reading these three. Remember that for the same set of data, which is what we are seeing in the left hand side window here, you will get three full questions. Okay, three full questions means this is one question. This is similar to the table and all which we saw where three parts are. This is one question. Once you finish this one question, you will get two more questions from the same emails. So total three questions. From a time management point of view, you can give easily at least 8 or 9 minutes to this whole question, because you are going to get three questions, which means don't read the data in a hurry. Give it some time. Even if it takes 3 minutes, 4 minutes to understand the three emails, which it will not take that long, but in case it was a slightly confusing table or a graph, you might have needed some more time. Even if it takes that much time, it's perfectly fine, because once you are clear, the questions will go faster. And you need to be clear so as to not make silly mistakes in 1 out of 3, because even if one goes wrong, everything goes wrong. So now let's go through the three emails one by one. So you can start reading the first email. Okay, so this email was from the admin to research staff. Now we'll move on to the second email. Okay, so in the second email, there is some important data which you have to capture. That they want 700, they have got 350, means they need 350 more. That's one thing we know. Second thing we know is that the payment is $50 per completed questionnaire, which means that already they have given out $17,500 for the 350 applications that they have got. Now he's asking him for the budget, which will come in the next email. And the third thing he's saying is that there's a probability of 40% that we get a response. But he's also saying it does not mean exactly 400 for every 1,000, but that's the probability. So these are the facts given in the second email. Now the third email. So here the answer to the budget is coming, 45K, 45,000 budget with a $50 per person rate means you can pay 900 people without exceeding the budget. Yeah, we'll go back to it for the questions in any case, don't worry. Okay, so the second one is, yeah, so this email is saying that the total budget right now is enough to compensate 900 people, okay, out of which 350 people have been compensated, which means you have still enough money left for another 550 people. That is what we know from here, and some other things he's saying. Okay, so now let's move on to the questions. They're asking us, consider each of the following statements. Does the information in the three emails that we read support the inference as stated? Which means clearly the three options, the three statements are playing the role of an inference. We have to answer yes or no, which means can we draw such an inference or can we not? That's what we have to do on this question. Let's read the first statement. The admin is unwilling to invite as many in the second group as were invited in the first group. Do we get this answer from the first email? Not really, he's just asking questions, so there's no clue coming from the first email. Do we get it from the second email? Obviously not, because the project coordinator is replying and these are his stats and these are his questions. So what the admin is thinking, we don't get to know from the second email. Do we get it from the third email? What do you think, yes or no? The admin is unwilling to invite as many in the second as the first. Can you infer such a thing? Yeah, correct. So no is the correct answer because there's no way on the basis of what will you say that he's unwilling. There's no clue at all. So we have to mark a no for this first sub question. Let's now move on to the second sub question. The project coordinator does not expect to be able to meet the goal of for numbers of completed surveys received. For this, we will have to read the second email once more to see if there was something we are missing out. So what we summarized earlier was that from what he's telling us, 350 he has got, 350 more he needs. 350 more he needs, and he has a probability of 40% approximately. So he'll need to send out approximately 900 invitations. So 40% is 360. He'll need to send out. Already we have enough budget, first of all, for more than 350. Correct? The budget that is available is enough to even compensate up to 550 people, which means even if the probability goes against him slightly and 50% of 900 people respond and you have to pay 450 of them, or even if 60% respond, he still has enough money. So there's nothing indicating that he will not meet his goal. Secondly, the admin is telling him that we'll compensate in the second group as well, whoever submits. So he's not even in any way telling him that you cannot exceed your budget. So everything is pointing to the fact that we cannot conclude that he does not expect. There's no way we can infer this. So we have to again mark a no for the second sub question. Okay. Now the last sub question. Think of this, yes or no? Come on, yes or no? The admin is willing to accept some risk of exceeding the budget. Come on, all of you guys are working. Okay, your boss is writing something like this to you. What does it mean? So most of you are saying no. Jaren, you have changed your answer 3 times in the last 2 minutes. Anyways, now let's understand how to go about with this. Clearly, the answer will come from the last email, and let's see the language that is being used. That will give us the clues. One of the things that the admin is saying very clearly, he's asserting something, is this sentence. Look at the tone of this sentence. He's saying we will honor our commitment to pay $50 to each and every participant, first group as well as second, who completes and submits it by the deadline we specify. What is the meaning of such a sentence? Is he rigid that I will not pay unless it's this much? Or is he saying, no, we will honor, no matter what we have to shell out, we will honor? So this sentence is very clearly pointing towards his willingness to take on some risk, even if it means we are going to exceed the budget. There's a second sentence which is coming at the end, which is what some of you took note of. Try not to exceed. Try not to exceed. In the past, students have told me that in our office, when our boss says try not to exceed, he means don't exceed. Now that may be your boss, but in general, when we are looking at this language in an email, try not to exceed the budget, it also leaves open the option of exceeding if need be. Okay, if he didn't want to exceed, he would be very clear cut and say that, look, I will only give you $45,000. Rest of it you pay from your pocket. He's not saying that. He's saying two things. First, he's saying we will honor our commitment. This is our budget. We'll honor our commitment. And second, try not to exceed. So he's just suggesting to him that when you plan to send out questionnaires based on what you know, probability this, that, make sure that we don't end up paying too much and overshoot our budget significantly. So overall, it's pointing to his willingness to accept some risk without any doubt, and the answer to this is yes. We can infer this. Okay, so whatever you achieved in the first two all got nullified in the third question, and this will be counted as one wrong answer if the third one goes wrong. Okay, but this is the biggest challenge of integrated reasoning, that you have to be very, very careful throughout, especially in these sets of 3 sub questions, because one of them also going wrong nullifies all the effort in an instant. It doesn't give you even partial credit. So you have to do each and every sub question carefully. Okay, that is what makes IR challenging. In my earlier video, I have already suggested that there is no need to target all 12 questions. In fact, don't do that, because the moment you target all 12 in 30 minutes, you are averaging 2.5 minutes per question. Now, 2.5 minutes per question may or may not be adequate depending on the question. This will come as a set of 3. So that's why 7.5 minutes you will have for all 3 put together, but you will still try to rush and then you might go wrong in one of them. Target maximum 10 out of 12 good attempts. 2, you be prepared to just guess and move on after looking at the graph. You'll see you can expect at least one bad graph and expect at least one bad 2-part analysis. Okay, most likely out of the 4 question types, these 2 will trouble you slightly more. On the other hand, tables and this question type, multi-source reasoning, is usually more dependable and more scoring if you give it some more time. So here you should try and get around 5 or 6 questions right minimum. And from the others, it's okay even if you make 1 or 2 mistakes in each of them. So that way you will still be bang on target. So target 10 good attempts. Okay, so strategically don't mess up IR in trying to chase perfection or a very high score, because it can easily backfire. As we are seeing, that's because of the nature of the questioning. Instead, be more realistic, allow for some questions to just go away, but focus all your attention on the others well and get all of them right. Okay, so this is broadly the strategy we'll adopt for integrated reasoning. I hope you found this video informative. If you're new to this channel, consider subscribing. That way you'll be notified every time we upload new videos.